Hey guys, this is the notes for 5.4. This deals with linear inequalities, so the graphing of linear equations using the inequality symbols. A linear inequality is going to be similar to a linear inequation, so it's a linear equation, but it uses inequality signs. Meaning, right, greater than or less than or greater than or equal to or less than or equal to. And now we also get solutions to a linear inequality. So these solutions are all the ordered pairs that make the inequality true. Okay, so you'll kind of see once we start to graph, but these solutions are all the ordered pairs that make the inequality true. So we'll see when we graph, there's like a range of all the solutions, and then you'll see the points that are in that range, essentially. Now we can determine which ordered pairs are solutions to certain inequalities by just substituting in the x and the y. Okay, so in this example, right, we have this equation here. We're going to substitute in and make sure that the statement is true. Okay, so whatever the left is should be less than 15 when we plug in 2 for x and 5 for y. Same thing for the rest of these. We're going to plug them in. So we get 2 times 2 minus 3 times 5 should be less than 15. So we get 4 minus 15 is less than 15. And negative 11 is less than 15, right? That's true. So yes, this coordinate 2, 5 is a solution to this linear inequality. Okay. So we can do it again. Let's try this next one. All right, plug in negative 1 for x and negative 7 for y. So 2 times negative 1 minus 3 times negative 7 needs to be less than 15. We get negative 2, and then we get plus 21 because negative 3 times negative 7 is positive 21. And then we get 19 is less than 15, right? No. That's not true, so it's not a solution. All right, so you guys can try the next two on your own by plugging in x and y into that equation. But right, if it's true, then yes, it's a solution. If it's not true, like the second one, right, 19 is greater than 15, not less than, so it's not a solution. All right, well, now we're going to look at actually graphing the linear equalities to show all the solutions. So that was showing it algebraically by substituting them in. Now we're going to do it by graphing. So our first thing we need to do is put it in our good old slope intercept form. That's the one we use almost every time to graph these linear equations, right? Y equals mx plus b. All right, I'll just reiterate that. And one thing, right here, this is important. We've done this a million times when looking at inequalities. When you multiply or divide by a negative number, you need to flip the inequality. Okay, so for example, right, example over here, right? If we have, I don't know, 2x, sorry, negative 2x is greater than 8, right? If we divide by negative 2 to solve for x, we need to flip the sign so it becomes x is less than negative 4. See how the sign's flipped? Right? So if you multiply or divide by a negative number, you need to flip the inequality. Okay, so that was one of these things. All right, now once you have in slope-intercept form, you want to graph the line. Okay, so we have 4 inequalities. One's greater than, one's less than, one's greater than or equal to, one's less than or equal to. So for when we have greater than or equal to, or less than or equal to, we're going to use a solid line. Okay, so you're just going to make a solid line for that linear equation. When you just have greater than or less than, we're going to use a dotted line. Okay, solid if it's greater than or equal to, less than or equal to, dotted if it's just greater than or less than. Now, when we have our line and we start to graph, right, a linear inequality has a bunch of different solutions. So what we do is we kind of color in or shade in the area of the solutions. So we're going to shade above the line for when we have greater than or greater than or equal to. Okay, so we're going to go above for greater. Kind of makes sense. And then we're going to shade below if we have an equation with less than or equal to. Okay, so above for greater, below for less than. And then if it has the equal sign, we use solid. And if it doesn't, then we use dotted. So, right, let's start to look at an example. Our first step from what we went over was put it in slope-intercept form. So that means solve for y. Okay, so we're going to move the 2x to the other side. We get negative 3y is less than negative 2x plus 15. And then we need to divide everything by the number in front of y. Now, remember, we're dividing by a negative, so make sure we flip the sign, right? Flip. Okay, so we get y, and then we flip the sign, so it's greater than, and then negative 2 over negative 3 just becomes 2 over 3x, and then 15 divided by negative 3 is negative 5 or minus 5. Right? So all we did was flip the sign because we divided by a negative, and then we just put it in slope-intercept form. Okay. Now, right, we have a greater than sign. Okay, so if we have a greater than sign, that tells us it's going to be dotted, right, because it's not greater than or equal to, it's just greater than. It's going to be a dotted line, and because it's greater than, it's going to be above. Okay, so we're going to shade it above that one. All right, so now we actually have to graph this line right here. Okay, so we have negative 5, right, as our y-intercept. Okay, so that's our first point right here. That's your y-intercept. So that's my point here. And then our slope, or m, is 2 over 3. So we go up 1, 2, to the right 1, 2, 3. Make a point. And now we just make a dotted line through those 2 points. Okay, because it's just greater than. And then again, we're going above it. So what we're going to do is shade it or kind of make these lines above that line because it's greater than. If it was less than, we'd make it below it. But in this case, we're making it above it because it's greater than. All right, so So we'll do a couple of the examples and then I'll have you do some on your own. So let's go through 2 and 4. Okay, so this is already in slope intercept, right? So all we're doing is graphing this line, right? Now that is less than or equal to. So less than or equal to tells us it's solid and it's below because it's less than. Solid and below line. So graph our y-intercept, -1, which is right here. And then our slope is -2/1 technically. So we go up 2 to the left 1. Up 1, 2 to the left 1. You can keep doing it and make multiple points, or you can just make that certain one. And then we make our solid line through these points. Okay. Now, we said it's below, so we need a shade below the line. Okay. All right, number 4. All right, we need to change this to slope intercept. So get the y by itself. So minus the x first. So we get -4y is less than -x plus 8. We divide by -4 to everything. And what happens when we divide by a negative? Well, make sure you flip the sign. Okay? So make sure you flip. So we get y is greater than, and then we get -1 over -4 is 1/4 x. And then 8 divided by -4 is -2. Okay, and now we're going to graph it, but first, right, we have a dotted line because it's just greater than, and then it's above because it's greater than. So we get -2 is right here. Up 1 to the right 4. Up 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Okay, so we're going to make our dotted line here. Doesn't have to be perfect, right? And then it's above, so shade above. All right, I'm going to do number 7 with you, and then I'll have you guys try the rest. So we did 2, 4, and we'll do 7. So I'll have you try 1, 3, 5, and 8. Oh, 6 and 8 too. So on your own. So we're not going to do 5, but I'm going to say try 1, 3, 5, 6, and 8. Okay, but let's first go through this last one. Now we have y is less than or equal to -4, right? So first, right, we're going to have less than or equal to, so it is solid. And less than tells us below. Okay. So solid and below. Now, when we have y is equal to line, remember that's a horizontal line at that y point right here, -4. So we're going to find -4. And then we're just going to make a horizontal line. That means left to right line. Again, it's solid. And we're saying everything less than or equal to that, right? So that means everything below that line 2 is included. So we're going to shade it below. Okay, and that's it for 5.4. So again, try those 5 problems. Let me know if you have any questions. You can inbox me on Remind or Google Classroom or email.